So now let's talk about position and displacement. Position and displacement both play a very important role when it comes to talking about motion in physics. What is position? A complete mathematical description of a motion of a particle is obtained by knowing the mathematical dependence of its position with respect to a user-defined origin. A function x equals x as a function of time will give us all information about that object as it is moving through time. So in order to do this, we need to be able to define a coordinate system x and y that starts from 0 and be able to build on it, and as the position of the object changes, be able to plot that on this xy graph. So in order for us to understand what we mean by position, we can look at this example. The position of an object describes its location relative to some origin or another reference point. So for this course, what we are going to do is we are always going to start off by defining an origin, stay at point 0, and then we are going to put our object at a certain position, and that is going to determine how far or what the value of this position is with respect to time. Now please be careful. If you see these two, let's suppose that they are both at the same instant of time, but they depend on my user-defined origin. So please make sure that you understand how important it is to define your origin correctly. So let's suppose that we define our origin to be at the center, so the positive line will go towards the right and the negative line, number line, will go towards the left. If your object is located at this position, what we can say is your object is at x equals +2. If on the other hand your object is at -2, that means your object is towards the negative side of the number line. Note, magnitude-wise, the plus and minuses are very important. Please do not ignore them while you're solving problems. Displacement, on the other hand, is a change in the object's position. It depends on the beginning and the end positions, and not any of the positions that your object may have taken while moving from one spot to another. So displacement, in other words, is the shortest distance between the 2 points, defined by xf, which is the final position, and xi, which is the initial position of your object. So for example, if your ball is initially at x equals +2 and it is moved to x equals -2, what is the displacement of the ball? So if your object final position is -2, so you put in minus, and your initial position was +2, you put that there, so your displacement is actually equals to -4 centimeter. Again, please be aware of the minus signs. You cannot ignore the negatives when you're solving problems, especially with vectors. So now let's look at an example. A mule hauling corn to the market. A mule hauls a farmer's wagon across a straight road for 4.3 kilometers directly east to a neighboring farm where a few bushels of corn are loaded onto the wagon. Then the farmer drives the mule back along the same straight road, heading west for 7.2 kilometers to the market. Find the displacement of the mule. Okay. So for this problem, there is a mule. He starts from this point and he goes straight out this way, 4.3 kilometers, heading east, and then he comes back heading west all the way to the market, 7.2 kilometers. Okay, now there's multiple ways of doing this problem, but there is one way that will make our life a little bit easier, and what that would be is if I define my origin sort of to be here. Okay? So now note very carefully, we are now not talking about the distance traveled, but we are actually talking about the displacement. So in that case, look what happens when we go when the little guy is moving, right? He goes all the way here. So he is covering a distance, absolutely. But when he returns back, to where he started from, his whole displacement is actually equals to 0, right? So delta x1 for this side is 0 because he doesn't have any net displacement. But as soon as he starts moving this way, there is now a displacement. So note very carefully, he is moving now towards the negative side of the problem, right? This means that this 7.2 kilometers is towards the left. So my delta x, which is my net displacement, is going to be minus 7.2 kilometers, because that's the distance he moved, and this is what my delta x net is going to be, plus 4.3 kilometers, because I know that this direction they moved towards the positive side, right? So if I do a quick math, what is the answer going to be? It is going to be minus 2.9 kilometers. Okay? Now, this is a vector, right? So displacement is now a vector quantity. What does my minus sign indicate? My minus sign indicates is the fact that I am now moving west, right? Or towards the negative side. So now for our next question, the question says at 3 p.m. a car is located 20 kilometers south from its starting point. 1 hour later, it is 96 kilometers further south. After 2 more hours, it is 12 kilometers south of the original starting point. What is the displacement of the car between 3 and 6 p.m.? What is the displacement of the car from the starting point to the location at 4 p.m.? And what is the displacement of the car from 4 to 6 p.m.? This is our question. So let's start looking at the problem. So let's say our car is located here, and that is going to be my original point, so I'm going to call it my origin. And at 3 p.m. the car is located, it has moved towards the south, and it is 20 kilometers towards the south at 3 p.m. Okay? Next it says, 1 hour later, which makes it 4 p.m., the car is 96 kilometers further south, which means that from here, we need to move all the way down. This is 96 kilometers, and that means it's 4 p.m. Okay? So the total distance between here and here is 96 plus 20, which makes it 116 kilometers. Okay? Now, it says after 2 more hours, it is 12 kilometers south of its original starting point. So, goes here and goes all the way back. So it is somewhere here, which is at 6 p.m. It is at 12 kilometers south of its original starting point. Okay? So now it's asking us, what is the displacement of the car between 3 p.m. and 6 p.m.? So at 3 p.m. the car was here, and at 6 p.m. the car was back here. Okay? So now what is the displacement? So the distance that the car traveled was all the way down, and then it returned all the way up. But what is the displacement between these two positions? So displacement delta x between 3 p.m. and 6 p.m. is actually equals to 20 kilometers minus 12 kilometers. So the total displacement is 8 kilometers. For part B, it is asking what is the displacement of the car from the starting point to its location at 4 p.m. So now, delta x from starting to 4 p.m. Okay, so if I was to start at the origin here and we'll work my way all the way down here, what is my displacement? It is 20 kilometers plus 96 kilometers, which equals 116 kilometers. Okay. Now for part C, it's asking me what is my delta x, which is my change in x from 4 p.m. to 6 p.m., right? Where am I at 4 p.m.? So from 4 p.m. to 6 p.m. That means I, right now, am at 116 kilometers at 4 p.m. And then we're going to be at 12 kilometers at 6 p.m. So my total displacement between these 2 points is 104 kilometers. If I've done that math correctly, right? 6 minus 2 and so on and so forth. So this tells us the displacements at each of these separate points.